All right, hi everyone, and welcome to Proving Grounds. So I'd like to start out by thanking our sponsors, especially our stellar sponsors, Versprite, Protivity, Tenable, Amazon, and Source of Knowledge. So this track is being recorded, and we're also streaming. At the end, we're going to have a Q&A session, and I'll be running the mic around, so just please bear with me and wait for the mic. Our next talk is on DNS hardening, proactive network security using F5 iRules and open source analysis tools from Jim Niederauer.
There you go. You got it. Perfect.
I got it?
Perfect.
Awesome.
Very good. Very nice.
All right. Let's. Jim works as a senior systems administrator at AppRiver. Please join me in welcoming Jim.
Save that. I'm only here to teach. I'm not here for me. All right. So I had trouble with the projector yesterday, so I'm going to roam around. Hopefully this laser pointer will work. Hopefully everything will go well. My name is Jim Niederauer. I'm a senior systems administrator at AppRiver. I've been working at AppRiver since 2006. First, I want to thank my mentor, Dave Lewis, back there. Thank you for your help and assistance. I appreciate it. And I want to thank B-Sides for inviting me to be here today. How about a big hand for all the volunteers who put this on? They're the ones that deserve the credit. All right, see if this works. No, I hit the wrong button already. There we go. So, a little bit about me. How did I get here? Well, I went to NOLACon in 2015 and was sitting around talking, teaching people about a few things that I was doing at AppRiver. A couple guys overheard me, like this says here, and they said, why don't you come speak at our next event? Well, so apparently you say a few things and some people over here you're a security expert. So realistically, I've been with AppRiver since 2006. This certificate is not mine because my name is Jim, I'm not Jack. When I came to AppRiver in 2006, I started out on their security team. Right now, I'm in charge of running their global data centers worldwide. We have 12 data centers that we run all of our servers out of and 8 offices globally. We run SecureTide, which is a spam filtering platform, and SecureSurf, which is a DNS filtering platform. The opinions expressed here are not necessarily those of my employer. They are mine and mine alone, so if you have any trouble with it, come after me, not AppRiver. All right, so today, what I'm going to do, I'm going to lay out, challenge what we were faced with. I'm going to tell you a story about how we went and put together a solution to secure our DNS infrastructure. And when I'm focusing on DNS here, I'm talking about our SecureSurf DNS infrastructure. And just the fact that it's just think of it as a DNS cache resolver and don't worry about what the service does other than it resolves DNS. Any of the things that I mentioned here, the different platforms, I'm not endorsing any one of them. We just pick them and we use them for our platform. So I'm not here to say one vendor is better than another. We just use what works. So what I'm going to do is lay out the challenge that we faced. I'm going to examine some of the security flaws that we ran across when we brought on our service. I'm going to look at some of the tools that we use to solve those security tools, or those security issues. I'm going to assemble those pieces into, to show you how we put them all together. I'm going to show you some of our results, and I'm going to discuss some of the future possibilities. Now, that's a lot in 20 minutes, so I'm not going to go into a lot of detail about some of this stuff. A little bit later, after the talk, I'll put some more technical blogs at Tripwire and on the Peerless blog. So the first thing, we'll start with basics. Before I came to AppRiver, they had version 1 of their SecureSurf service. They rolled it out. The service did what it was supposed to do, it secured your DNS. The problem was it took about 500 to 1,000 milliseconds to resolve DNS queries. So if you really like your DNS slow, that worked well. It didn't work too well, so they started from scratch and rewrote the whole service. When I came on board, they were about to roll out the service for the second time. And what we ended up finding out the minute we rolled out the service was that when you put a service out there that anybody can connect to, you run into all kinds of problems, right? So what they ended up doing in our DNS service works at application layer 7, obviously, and a lot of people will secure their DNS at layer 7, basically by setting rules where you block IPs and only resolve for certain domains, that sort of thing. Well, we couldn't do that. We had to work at layer 3, layer 4, layer 5, and layer 7. So what happens if you wait to secure DNS at layer 7? Well, you end up with something like this, right? You're going to blow up your DNS servers. There's so much traffic out there. There's so much malicious traffic. You're not going to be able to support security for that platform. So what we ended up doing was developing a plan to figure out how we could mitigate some of the challenges without closing that DNS. The reason we didn't go with a whitelisted IP-based DNS service is because some of our customers are actually remote customers. So they move around, they have dynamic IPs, they're small don't always have a fixed IP. And they don't want to have to log into a captive portal, put in their IP address, and wait for that information to be propagated back to the service. So what I'm going to go over today are basically the security flaws that we found in DNS that you probably see in your own environment. And I'm going to show you how we went to solve those problems in general detail. And if you want more specifics, feel free to come find me. I'll be here the rest of the week. I'll be at DEF CON. I'll be glad to sit down and go over some specifics. I'm not showing any live demos today because we all know how those go when we do those in talks. All right, so the first thing we came across, I don't know if I get your word, tell me, DNS amplification attacks. Who's seen these on their network? Are you been a participant or a victim? Not disclose, right? So they're a man-in-the-middle attack where somebody spoofs an IP address, sends you a bunch of small packets asking for a bunch of big packets, and sends them to the spoofed IP address. Typically a botnet network, you can rent time on them. They'll do these to the tune of several 100,000 botnet members over the course of 15, 20 minutes. Your DNS just doesn't work, okay? DNS amplification attacks are a big deal. They really will bring your DNS down or make you look stupid for participating in them. So you have to be careful about these. The next problem we face is kind of an interesting one that we saw. Being a spam and virus filtering company, we're very aware of what's going on the botnet networks, who's sending out spam and those sorts of things. But we saw this in our DNS. There's a tactic that the malware developers use called domain generation algorithms. And what they do is they're built into their malware, and they generate these randomly generated domain names along with the domain names that are real and connect to the botnet command and control networks. And they do this on a regular basis so that what they're trying to do is obfuscate their real DNS command and control in this scattered traffic. Well, the problem is on a small network, you may never see them. On a big network like what we're doing 60, 70, 80,000 DNS queries a second on our network. These things become problematic because they generate a ton of NX domain lookups. So your DNS servers become very slow and don't respond very quickly. The third thing we saw, bad name queries in our DNS. So everybody here, I'm sure your DNS never relays a DNS request outside your network that it shouldn't, right? So one of the big ones, there's one on here that you all need to be aware of. I think it's listed here, WPAD queries. If you don't have those shut down on your network, I advise you to dig through the internet and figure out how to shut those off immediately. If you don't have a proxy server on your network, these are bad news. Your users can go, and this is an aside, they can browse in Wi-Fi anywhere else. It will send out these queries. Somebody can spoof DNS queries and reply to them. It will set the proxy server on their browsers and send all their traffic to that proxy server. Okay? Disable that if you don't use it in your domain. Take me seriously on this. But what we also saw were some really strange lookups. I don't know if you can see that. There's one there. There's a couple others down here. Some pretty poor malware writers. What they were doing was using these domain generation algorithms to generate domains from botnet command and control traffic, but they weren't smart enough to make them fully qualified domain names. So they just ended up creating a lot of havoc on it. So we saw these in our network. Another thing we saw when we started examining DNS traffic, and initially we're examining all of this traffic using Wireshark and some other capture methods. We saw malformed DNS packets. There's two kinds of things that we saw in this. One of them was malformed packets designed to basically DDoS your DNS server, bring it down. And the other was really interesting. I don't know if you know about DNS tunneling, where you can actually tunnel other protocols through DNS. It's done by packet injection of the packet headers that go through your DNS server. And you can see that in your DNS requests if you look at enough packets. So this was a problem. These kinds of traffic should never, ever reach your application servers. They should be blocked at the edge. The next thing we saw was data exfiltration via DNS. This is pretty slick. So the nefarious people register a domain like ps780.com was one of them. Then they go and they do drive-by malware downloads, send you some malware via a banner ad, for example. Installs some malware on a computer, starts generating traffic, looks for the data that it's looking for on that infected machine. As soon as it finds it, it starts taking that data off the disk and creating this encoded subdomain. So the problem is that all of this is legal DNS, right? Goes out to the root, finds the name servers, goes to the nefarious name servers, it returns an IP address. The other thing it does is it takes all of this data here in a subdomain and re-aggregates it back on the nefarious side. So they're exfiltrating data. This is what this is, data being exfiltrated from an infected customer. So you can catch that in your DNS, and we were able to mitigate that through some of our F5 iRules. Another thing that we saw, because we didn't want to close our DNS resolvers down, is we wanted to be able to block IPs that we knew were bad. And there's several lists out there. This particular one is a drop list from Spamhaus. It's free. You can subscribe to it. You can download it whatever you want. We wrote a little C# program to put it in the right format. This is the format that an iRule data group takes, but it's basically just the data gotten from Spamhaus to put in the right format. We're able to have this data stored in a central location and then distributed to all of our F5 load balancers globally with a bash script and cron jobs that are run every so often on the F5 load balancers. So we're able to aggregate these. We get this data from various feeds, including our own spam filtering information. The last thing we saw is actually an interesting way that you can use DNS to DDoS. So probably a year and a half, 2 years ago, most of the major DNS servers put in a feature that allow you to force certain queries to be re-asked over TCP. So somebody wants to do a DNS amplification attack, they hit your server with an any request on port 53. Your DNS server says, I'll be happy to answer that. You've got to ask on TCP port 53. Well, the bad guys aren't going to initiate a DNS amplification attack against you over port 53 TCP, because then you know who they are. But what they will do is they will spoof the IP address in the TCP packet and send you a boatload of queries directed at the malicious IP, or the IP address that they put in there, the wrong one. So what do? You end up initiating a SYNAC flood against the target IP address. So one fix for vulnerability creates another vulnerability in your DNS. So be careful about these. In Windows, if you run Windows DNS, anybody know what the timeout is for TCP timeout on Windows? 5 minutes. 5 minutes. That's ridiculously stupid. Nobody needs 5 minutes of timeout, wait, timeout. You can change that in the registry. The lowest Windows will let you set it is 30 seconds. But set it to 30 seconds. That will protect you quite a bit. All right, so this is, the last thing we saw in our DNS were DNS floods. This was kind of interesting. When we first brought the service up several years ago, this was a big deal. People would just try to flood the crap out of you with these DNS requests. The latest one happened last year. I think it was October or November. Anybody remember what happened to a particular magazine? They made an announcement about the content that they were putting in their magazine. The next day, the unhappy people DDoS Ultra DNS for about 4 hours in the afternoon, took them offline. This was Playboy magazine. So anybody that associated with Ultra DNS that afternoon had a really crappy afternoon. All right, so what did we use? So I'm going to go over the pieces that we used to put all this together. First thing, we have our F5 load balancers. These were in place when we got there. We're just working with the tools that were in place. So basically, an F5 load balancer has a public-facing IP address. It's an endpoint for a service. It could be email, it could be DNS, whatever. It's called a VIP, a virtual IP address, and its load balances to a pool of servers in the background. In our case, there would be port 53 here and DNS servers in the background. It also supports something called iRules, which are very cool. I'm going to go over those in a minute. It lets us actually monitor what's going on with these and load balance across many servers in the background. It has some other features. It uses an operating system called TMOS. Stands for Time Managed Operating System. Nothing fancy. It's just F5's operating system. And it has the ability to do TMSH commands, which run functions within that operating system. Another cool feature that it has are iRules. Now this is just a view of a sample iRule in F5's free iRule editor that you can download online. So iRules allow you to manipulate traffic at the application or network layer, both inbound and outbound, and do things with it. And it uses a language called TCL, Tool Control, or Tool Command Language, I think that stands for. So anybody remember TCL from a long time ago? Well, it's back. All right, so what we also were able to do is threat feeds, and I spoke about these a little bit earlier. That's the address. You can go to that one and look up that particular threat feed. If you have a router or something, a firewall that takes in these IP feeds, I would go look at this one in the eDrop and just drop that traffic from your network, never let it touch your network. There's one called Drop, and there's another one called eDrop. It's a free list that you can download. So I was hungry for bacon this morning, but I didn't get to breakfast in time. So I was waiting for my badge, so I put that in there. The other thing the F5 allows you to do is remote logging, and this is where we kind of put the pieces together. F5 lets you log locally, obviously, but you don't want to do that. Anytime you're logging locally on a public-facing device, you're creating IOPS on your disk, slowing your device down. So what this allows you to do is set up paths to remotely log all of your data. We remotely log all of our data to Graylog. Graylog is a choice that we did. It's basically the open source alternative to Splunk, right? People use Splunk. We chose not to use it. We generate so much data, the cost for us to get involved with Splunk, it's a great product. But for us, we needed something that we could manage a little bit more because the volume of log data that we have is tremendously high. So Graylog is, you can run it as a single machine, a cluster of machines, put the cluster behind an F5 load balancer, send all of your data to that F5 load balancer, load balance it across the Graylog servers. Graylog has inputs that ingest this log data, takes that log data and writes it into an Elasticsearch cluster that lives behind this. So we're using Elasticsearch as well. The Elasticsearch cluster then indexes all the data based on the fields. One of the cool things about Graylog is that it gives you the ability to import data in a format called GELF. And I'm going to go over that in just a second, what that is. So GELF like ELF, but not a GNOME or anything like that. The other thing it allows you to do is write custom Java plugins so you can parse data when it's coming in. So how many of you use like Kiwi? Anybody remember what Kiwi is, syslog server? It was good for its time. It was hard to get information out of that, right? Because it just takes straight up syslog format, dumps it into a file. With the volume of stuff that we're doing, it craps out very easily. The Elasticsearch gives you the ability to do flexible search. You can format your data in certain ways. I'll go over a little bit of that here coming up. The other thing that Graylog has now that's pretty cool is it lets you, from your Windows or Linux boxes, you can ship your logs directly to it. And it has a feature that's called Graylog Sidecar. It's an application you install on a Windows server or Linux server. And it manages either NXLog or Logstash. But the cool thing is it reports back to your Graylog. So through your Graylog web interface, you can manage all your remote endpoints. You can tell it which files and logs you want shipped back to your Graylog servers. So NXLog is basically, think of a log router. You point it to a folder that contains your logs. It ingests those logs. It will do a transform on them, put them in the format you want, and then it will send those logs on to whatever input you tell it to. Grabs the log, does its thing, sends it off. That's all it does. It's a middleman. So what we use this for, this part of it, is because we wanted to actually look on private networks what was happening in DNS for customers. So in DNS, most of these customers have Active Directory DNS servers. Active Directory DNS servers have the ability to output your log information in the debug logs, right? It's in a very crappy format. It's very difficult to read. And it's also difficult to make it rotate. Now, if you want to know how to do that, I'll put up a blog post about how to do it right so your logs rotate and everything else works the way it's supposed to. Because what happens by default in ADDNS, if you put on the debug logging, it will keep the file up until whatever size you set it at, 500 megs, 50 gigs, whatever size you set it at, and then it'll delete that log and start again so all your data is gone. With PowerShell, you can set some functions that will let you roll those logs over and keep those logs for a period of time. So, GELF. GELF is short for Graylog Extended Log Format. It sends data in a JSON formatted packet. The first parts of this packet are required for GELF format. The last parts are the cool parts where you can actually parse out and add your own fields, which we did to a high degree, and I'll give you some examples of that. But you could add 100 fields here if you wanted. If you can grab the data, you can put it in there. If you do any .NET program, any other kind of program, there's GELF libraries available to do this, or you can do it natively, which I'll show you in a second. In our F5 iRules, what we did is we actually told, in TCL, this is how you would write one line of code to send one log message to through the F5 in GELF format. But it's pretty straightforward. There's your bracket, all the information you need. Here's the fields that we were adding, right? So we're adding these fields down here at the end. All that data then hits the Graylog server in GELF format. There's a GELF input on a certain port, and it puts it right into Elasticsearch. The last thing we just started experimenting with in how to visualize our data is Kibana. I'm not going to go into too much about this, but it links up directly to the same indexes that are created by Graylog in your Elasticsearch cluster. Very cool solution. So built into our secure surf. So basically what happens is if a customer hits a domain that we know is either part of a botnet command and control network or is a drive-by download, it will trigger one of these alerts, and it'll give the domain that they hit and how many were blocked. And I've taken some of the data out of there, the customer's data and the IP address and all that, but it tells you what policy and everything else. So what we do then with this is there's a timestamp on this, and we can go back to our data and actually find in the data where that is. And I'll show you where that infection is and what machine on the local network is infected. And I'll show you that here in just a second. So real quick overview. Basically, from a customer perspective, they'll have a DNS server or multiple ones. Their DNS servers are set to forward their DNS requests to us. When they forward those requests, they hit our DNS bit. We have an iRule in place. It's basically 900 lines of code, several sections. Each one of those sections addresses one of those vulnerabilities that I talked about earlier. The packet passes through those, cascades through that iRule. If any of the rules trigger a block, then the packet gets dropped, but everything is logged to our Graylog cluster. So we can see right away what's happening when somebody does a DNS amplification attack, for example. The F5s then have Chrome and a bash script that go out with TMSH and hit a web server that's in one of our data centers. It pulls out the data from those threat feeds. It does that every so often. So if we find over here that a particular domain is creating a DNS amplification attack, for example, and it's not in our threat feed, we can add it, and within 5 minutes, it's globally blocked from every DNS server that's out there. So it's a very quick way of pushing data to a whole lot of endpoints very quickly. So let's look at a little bit of the information that we get out of this. This is a Graylog interface. The fields that are coming in are over here. The time frame is up here. The query is up here. This is actually a histogram showing you per minute. This particular one is a DNS amplification attack. I don't know if you can see the domain name here, but that's the domain name. And it shows you how many are coming in. I believe that's about 1,000 per minute coming in. And that's from a very small attack coming in globally. Now, I know that I happen to be blocking these, but this is just the number of queries coming in, so we record all the queries that are coming in. We can actually split that out in Graylog. You can take and expand one of the fields, click on quick values in this case. You'll end up with a list of the top values in there. There's that domain name that was doing all the nefarious stuff. Over that time frame, it made that many queries. It was that much percent of our traffic. If I want to narrow it down, click that button, and it'll narrow the query down even more. We have dashboards that run in our Network Operations Center where we can manage this. This is showing an hour view. So over here, these are all, in this case, DNS any queries that are coming in. These over here are the ones that are getting blocked. So what we can do is we can compare the two, and if there's something missing over here, we can add it to our iRule data group, have it pushed out, and have it blocked pretty quickly. This is an example of, remember the spam house list I showed you? I think that's the name of the list up there. These are actually all the blocks of people trying to hit our DNS servers coming up here. So there's that many hitting it, and these are actually getting blocked. So we can tell that our blocks are working. This here is showing network compromise. There was a particular domain that we saw in a CTN. We were able to go back to our public-facing VIPs and find out the two customers that were generating those by their WAN IP addresses, contact those customers and get them in the process of cleaning up their network. This is an example of the data we get out of the DNS debug logs. These are the fields that we created in our custom Java plugin that takes the normal Active Directory DNS debug logs and breaks it out into useful information, not the crap that Microsoft has in their DNS debug logs. You can actually search it, find out what's going on. I have all the fields blocked, but you can turn on the source and destination IP, narrow it down to a local internal IP, and see all the DNS traffic that a particular user on your network's using. So if you want to spy on or find out what your users are visiting, you'd be surprised if you put this in place. You could build a VM and point the stuff to that and figure out what's going on very quickly. I only have a minute left. We're about 2 slides out here. This is just some more debug data, same thing. And the last thing is we could actually take that debug data, narrow it down by the domain name. I didn't show the IP address, but this shows one machine that's compromised with 8 DNS queries over the course of that week. We're able to tell the customer that machine on your network's infected, take it off the network, fix it, and that's the kind of information you get. Another thing we can do is we can look at where infections are coming from. It has built-in geolocation. Once you install the geolocation database, we're able to tell where any kind of data that's IP-based is coming from. So there's a lot of flexibility in this. We're about out of time, so our other possibilities that we could look at, we could look at some of these other things and create rules, create anything that we can do to export data and then analyze it can be looked at from a security perspective. So I know I gave you a lot of information. It was pretty high level. And if you have any questions, you can reach me there, and we're good to go.
Great, thank you.